Hello and welcome back to the channel. Today we are going to continue with the part 2 of our lesson or studies on the properties of operations and expressions. In the part 1, we look at the foundation of operations and expressions, and we established the fact that properties are rules that governs mathematics. And then operations, we have the operational signs like addition, multiplication, subtraction, and division. And we also established the fact that we need these rules or properties in order to be able to solve questions or expressions that have mixed operations, expressions that have multiple operational signs in them. So the properties or the rules give us the order at which those questions should be answered to prevent confusion and then help us to get or arrive at the same answer wherever you are in the globe. So today, if you haven't watched the part 1 yet, please, I encourage you to watch the part 1 because it's useful for the understanding of today's topic. So let's dive in to look at what we have today. Today we are going to look at the properties of operations. And I assure you that by the end of this video, you should understand what commutative properties, associative properties, distributive properties, and then identity properties. So you'll be able to explain or identify these different properties. And then you should be able to explain how they work with numbers and variables. Variables are just letters A to C we use to represent an expression. So these are some of the things that you have to understand at the end of this video. And finally, you should be able to apply these properties to simplify expressions. All right, let's get started by looking at the first property, which is the commutative property. Commutative property. The commutative property is from the word commutate, which means to move from one place to another or to change the order of something. So this property tells us that the order of numbers does not affect the result in addition and multiplication. So what we are basically establishing is that this property does not apply to division and subtraction. It's only applicable in addition and multiplication. So what it means is that when you change the position, the order at which a number or an expression or an equation is given, when you change that order, as far as addition and multiplication is concerned, there is no change in the result. So when you look at 4, we have 4 plus 5 giving us 9. The same thing, when you change the 4 and the 5, it doesn't change the answer. So 5 plus 4 is still 9. It does not change. And the same way multiplication, 3 times 7 gives us 21. So when you change it 7 times 3, it's still 21. It doesn't change. This is what we are talking about as commutative property. The reason why division and subtraction are not included is that, you see, when you have 4 minus 1, the answer is 3. The same way when you have 1 minus 4, the answer is not 3, but rather negative 3. So you see that subtraction is not commutative because the answers are not the same, they are different. The same way when you have 4 divided by 2, it gives us 2. But when you have 2 divided by 4, it gives us 1 over 2. So you realize that we have 2 different answers here. This means division and subtraction are not commutative. And why do we need this particular commutative property? Because reordering numbers can make calculations faster and easier. So when you are able to reorder the number, it gives us easier calculations. And we will not even stress ourselves in trying to calculate again, because we know that 5 plus 4 is 9, and then 4 plus 5 is still 9. All right, let's move on to look at the next type of property, which is the associative property. Now, the associative property means regrouping or grouping numbers differently does not change the result. When you group numbers differently, it doesn't change the result. So in associative property, excuse me, we associate the numbers. We put them into group. But in putting these numbers into groups, it doesn't change the result or the answer of the numbers. So considering 2 plus 3 in one group, we give us 5. And then we have 4. So if you add this to 4, you get 9. So you see that 2 plus 3 in one bracket plus 4 give us 9. The same way, when you decided to group the 3 and the 4, putting the 2 outside, 3 plus 4 give us what? 7. And then plus 2. So 2 plus 7 equals 9. So you see, it doesn't change the answer. It remains the same. So associative property is applicable using addition. Now let's look at multiplication. If you group multiplication numbers or expressions or equations, it doesn't change the result of what, or no matter how you group them. So we have 2 times 3 in one bracket and then times 4. Likewise, we have 2 times 3 times 4 in one bracket. So we first grouped the 2 and 3, and then we later came to group the 3 and 4. Now 2 times 3 is 6. When you multiply it by 4, you get what? 24. So you see here we have 24. Now when you are able to multiply 3 and 4 first, which give us 12. And then you multiply that by 2, we still have what? 24. So it tells us that multiplication and addition are associative. The same way in commutative property, addition and multiplications are commutative. So here too, division and subtraction are excluded because they do not qualify to this particular property. All right. So why do we need associative property? So when simplifying long expressions, you can regroup them. You can regroup those numbers to make calculations also what? Easier. That is why associative property is also useful and very important in this regard. All right, so let's look at the identity property. The identity property says that in addition, there is a number that when you add it to any value, it doesn't change the value. In multiplication, there is a number. When you multiply it to any number, it doesn't change the number. So when it comes to identity property, we are saying that numbers does not change the other number when added. So when you add 0 in addition to 7 or any given value, it doesn't change the answer. When you add 0 to any variable, it doesn't change the answer. Likewise, when it comes to multiplication, when you multiply any number by 1, it doesn't change the answer. And when you multiply any number by variable or any number, when you multiply 1 by any variable, it doesn't change the number or the variable. So in identity property, we say the identity element keep the original number unchanged, or it is the same. The original number does not change no matter what you do. So when you add 1000 to 0, it's still 1000. It doesn't change. When you multiply 1000 by 1 is still 1,000. It doesn't change. So this is what we are talking about when we say identity property. The number does not change. So think of 0 in addition as what? Adding nothing. And then think of 1 in multiplication as being what? Not changing the value. Okay? It tells you that whenever you are given something like this, you don't need to stress yourself by trying to calculate, because any number added to 0 remains the number, and any number multiplied by 1 will give us the same number as the answer. All right, let's move on to the distributive property. So as the name suggests, we are distributing. So we have 3 times 4 plus 2. So when we are distributing, what it means is that we are distributing 3 among the numbers in the bracket. So you share the 3 or you distribute the 3 among these numbers. So 3 will multiply 4, then you bring your plus, then 3 will multiply the 2. This is expansion of the number. So when we say we are distributing number, we are basically talking about how multiplication interact with what? Addition and subtraction. So in the interaction, we realize that 3 is multiplying the additions in the bracket. The two numbers that are adding, the 3 outside is multiplying them. So when you use 3 to multiply the 4, then use 3 to multiply the 2. That is how come we have 3 times 4 plus. So always the sign that is in between the two numbers in the bracket, especially addition and subtraction, they are the signs that connect the two products together. So 3 times 4, we have 12, then plus 3 times 2, we have 6. So this gives us 18. And then we have 5 times 8 minus 3. So the 5 is multiplying, or we are distributing the 5 to the 8 minus 3. So we have 5 times 8, and then we have 5 times 3. And remember, the sign, the minus sign in between the two numbers in the bracket is what separates the two products together, or separate the two products. So 5 times 8 is 40. So you write your 40, and then we have 5 times 3, which gives us what? 15. So when you subtract 15 from 40, we get 25. So this is what we call distributive property, and it happens in using variables as well. And it is just the relationship between what? Multiplication and addition and subtraction. So when we have A times B plus C in the bracket, it's just basically saying distribute the A among the B and the C. So we have AB plus AC. And then we have X into bracket Y minus Z, telling you that distribute the X among the Y and the Z, giving you XY and XZ. So this is what we call the distributive property. So you are distributing this particular, the outside number, among, or you are distributing them to those that are in the bracket. This property is very essential for expanding expressions in algebra and for solving problems efficiently. That is why it is very important for us to understand. So now let's look at how we can apply this in our real life. When you go for shopping, so you decided to shop 3 items which cost 10 plus 5 each. 10 plus 5 each. So you just basically, with your mathematical knowledge and the properties, you just distribute these 3 to the 10 and the 5, and then you will be able to arrive at your answer 30 plus 15, giving you 45 cities or dollars. Okay. So this is it about how we can apply that or these properties in our real life. And then sometimes in cooking, they said, okay, means 2 plus 3 cup flour. 2 plus 3 cups flour. So times 3. So 2 plus 3 cups flour times 3 is basically telling you, you know what? Just distribute this 3 among the 3 and then the 2. So giving you 2 times 3, which is 6, plus 3 times 3, which is 9. And then when you add these two together, you get 15. All right. So that is it in our real life, how these properties work. Okay. So learners, in a summary, I want us to understand that these properties are very important as far as our daily life and our academic progress is concerned. So we learned that commutative property is just changing the order, does not change the result. Associative property, changing the grouping does not what? Change the result. And in identity property, we establish the fact that addition by 0 or 1 multiplying to any number does not change the numbers or the value or the result. And we also establish the fact that distributive property is just multiply across addition and subtraction, telling us the relationship they have with addition and subtraction in simplifying an expressions. These properties help you and all of us as mathematicians to simplify calculations, working with variables, and also preparing for mixed operations. So when you are able to see operations or expressions that have multiple operational signs, you'll be able to utilize these properties in order to be able to arrive at a good result or answer of that expressions or equations. So learners, in part 3, we'll be applying all these properties step by step in some examples of mixed operations, both with numbers and with variables. So try as much as possible to watch the part 3 for further understanding as we solve more examples. Well done, learners, for completing this part 2 with me. Remember, if you haven't watched the part 1, go back first and watch them. And in part 3, you will learn how to use these properties in mixed or multiple operational signs expressions. We will look at it step by step with examples that you can follow and understand. And if you are yet to subscribe to the channel, I encourage you to like, subscribe, and turn on the notification bell. Comment in the comment section so you won't miss the part 3. See you in our next video, and God bless. Bye-bye.